You've got a smart telescope, or a normal telescope, or a full astro rig, maybe. And of course, you're taking pictures of the night sky, especially deep sky objects like galaxies, nebulae, star clusters, all this kind of fun stuff. But once you've taken all of those pictures, what do? You need to process them. So, of course, these days we have some simple tools in smart telescopes that let you do some kind of processing, AI enhanced. It's pretty good, actually, but it doesn't really reveal the full potential of the data that you captured. And you have some simplified software as well that's free. For instance, my friend Luke from the Lucomatico channel made Astro Wizard, excellent to get better results than what you can get in scope, but it's still, you don't have the full control and you don't achieve the full potential of your images. And if you want to achieve the full potential of those images, the data that you've spent so long capturing, whether it's from a smart telescope or something else, then you need to orient yourself to more advanced software. And there's stuff like PixInsight, which is very expensive but amazing. And then you can add some AI-powered sharpening and denoising tools from stuff like RC Astro or Cycon that are typically paid. So you're paying a lot of money, like more than the smart telescope itself, to do the processing. Or you could orient yourself towards free stuff. So, for instance, you have SETI Astro Suite Pro, which is free, or another piece of software called Siril, which is free and also has tons of plugins available for it that make it a full processing suite. And a lot of people are scared of Siril because it seems difficult to use. And in this video, I'm just going to show you how to use Siril, and it is not going to be difficult. Sure, there's going to be some setup to do. Sure, there's going to be some learning to do, but is it going to be difficult? Not really. Let's have a look. So everything I'm going to use in this video is free. And to be honest, and I'll go back in the video, but the impetus for all of that has been this book, the Siril book, How to Use It. It's very well done. I highly recommend it, whether you're going to start doing processing in Siril or not, because there's actually a lot of information, even general, that you can play around in Siril, and then you can go to PixInsight later on if you want to. I'm a big fan of PixInsight, but this opened my eyes to Siril. So we're going to keep everything free. The first step is, of course, to get everything that you need. So let's get started by downloading and installing Siril and any other plugins that we may need. Let's get to it. Okay, I'm on Siril.org. That's the website for Siril. You have a version for Linux, Windows, or macOS. And actually, Siril was originally meant for Linux, and I wanted to do this video under Linux because I also use Linux. But for some AI accelerated processes, it's actually easier for me to be under Windows. So that's what I'm going to show this time, but it's for basically all OSs. And of course, it's open source. So you can check the source code and make your own modifications to Siril if you ever want to. So let's go Windows. We're going to download the 64-bit version, and it's going to download. While we wait for downloading, well, you could consider getting this book. Seriously, it's awesome. So like the book itself has 5 or 6 chapters. One of them is just introduction and getting to install Siril. Another one is about pre-processing, which is stacking all of your images. Another one is about lucky imaging. You have processing, so after you've stacked, doing the actual processing. That's one of the main focuses of this video. And you have also analysis and science with Siril, like detecting extrasolar planets, that kind of stuff that are transiting in front of other stars, as well as in the end practical cases that you can download the full data from and actually follow a step-by-step. And in this video, we'll be doing one of those practical cases. I'm going to hide some of the secret sauce that is in the book because I don't want to supplant the book. But anyway, here we go. We also want to download something called Parallax Nano. This is a deconvolution tool, and the Nano version is free for Siril users only. So that's great. We're going to use that. And so you'll want to actually create a free account on the cycon.eu website, and then you can access those files for aberration correction, star reduction, and stellar sharpening. So let's download all 3 files. And then another thing that we want to download is Graxpert. Graxpert is an AI-powered tool, or non-AI as well, that will let you remove the gradients from your image. If, like me, you're imaging from a light polluted city, and by the way, I'm imaging from Tokyo, one of the most light polluted cities on the planet. So yeah, keep that in mind. But yeah, you will have gradients, light pollution, maybe moon radiance in your image, and they're very difficult to remove, or historically, they've been very difficult to remove. And then Graxpert came along and made everything simple. There's other methods as well that Siril supports and is very good at, but this is the most one-click method that's available. So let's download that. And for me, again, it's for Windows, but you have versions for Mac and Linux. In theory, as well, I think all of those PT files for Cycon also work under any OS that you may be using. So this should be cross-compatible between Windows, Mac, and Linux. Now I've downloaded everything. I've created a Cycon Nano folder under Documents. That's where I'll put the weight files that we just downloaded from the Cycon website, and I'm going to execute the Siril installer executable. So I just double-clicked on it. We're going to validate that and proceed through the installation of Siril. So select the language, it's going to be English. I'm going to accept the agreement, go forward, create a desktop shortcut. It's next, install, the usual stuff. I'll let it do its thing. Okay, then we have the option to launch Siril and to visit our first steps page, which is always a good idea. So you're gonna get some information about like first steps, but you know, I'm gonna cover all of that in this video, so you might not need that immediately, but there it is. Siril is open and ready to go. I'm going to install the other stuff that we need, which is Graxpert. So let me do exactly the same for Graxpert. Okay, I double-clicked on the Graxpert executable, and it will by default install only for your current user under Windows. Remember this path. It might become useful in the future. So I'm gonna Control-C there to not lose it. Open Notepad, copy-paste in there, that way I have it just in case. And we're gonna finish the installation. There we go, it's done. Click on Finish, and first thing, I'm going to launch Graxpert. Next, I'm going to load a random image in Graxpert using load image. There we go. And I'm going to go to background extraction, and I'm gonna go advanced here and say that my background extraction model should be 1.01, my denoising AI model 2.0.0, that's the one I recommend. If I click on calculate background, it will download as needed the AI model to actually do the background extraction. And if it doesn't, go to this advanced tab here and click on download the model. It should be available somewhere in here. And then same thing for denoising. Let's do a denoise image. And again, it should automatically download its AI model for denoising. If not, under the advanced tab, make sure you click on the download button and let's do its thing. So that's just preparatory work to make sure that we'll be able to use Graxpert from Siril. And now we can close Graxpert and forget about it. We probably won't need to use the interface anymore. So now we want to go into Siril. There's multiple things we want to do in here, but there are some first steps. So I'm gonna click on here. So I'm gonna click on this hamburger icon here, go to Preferences, and under Miscellaneous, there are several executables that can be set. One of them is Graxpert, so I'm gonna click on the folder there. I'm gonna paste the path to Graxpert that we had used earlier. So you see it's the path here that I had put in Notepad, select graxpert.exec, and now Siril just reminded me of something else we need to download and install, which is StarNet. StarNet is an AI tool that lets you remove stars from an image so that you can process the nebulosity, and then later on you can place back the stars into the image. And there are specific tools in Siril to actually let you replace those stars, and we'll get to those in the video. So for that, I'm going to go under the StarNet website here, and we'll want to download the command line tools. That's what we're going to use. And I need to scroll down to the bottom of the page. StarNet CLI tools is what I want to click. Latest version for Windows, and we have the choice between a zip file and an installer. I'm just going to use a zip file that I can extract wherever I want. And so now we're downloading StarNet, and I'll be able to unzip it and give the path to Siril. So I've unzipped StarNet, and I've put the whole folder with the executable StarNet2 into my documents. So now I can point Siril to it. So let's go back to Siril. And we are going to navigate to the same folder after clicking the folder icon, select StarNet2, apply. So we've done one set of settings. There's a second set of settings, which is going to scripts, Python scripts. And for you, there's going to be nothing except core here. So you want to go to core because there's nothing else. For me, unfortunately, it remembered all of the scripts from my previous installation, so I cannot show you the basic state without anything, but you will get only the core here. And there's two important things to do. There's the GPU manager and the Siril catalog installer. Let's start with the GPU manager. The GPU manager basically lets you install tools that will allow any AI processes to use hardware acceleration on your PC or Mac, which makes everything faster. So you really want those. And you want to go on each tab. So first, you need to make sure that your GPU was detected. For me, it was. You can go to the Onyx runtime. And in there, what you want to do is click on Install Recommended. So let's do that, Install Recommended. And just like that, the installation is completed and everything is working. So it installed a version called DirectML, which is a Windows framework to let GPU acceleration of AI processes work for pretty much any GPU. That's very nice. I'm going to go to PyTorch. And because I have an AMD GPU, I wanted to go and select Torch plus ROCm 7.2 Win, right? Because I have an RX 9000 series card and I'm under Windows. I'm going to click on Install Selected Variant, click Yes. Otherwise, you would need to just click Install Recommended and not think about it. So now I have proper hardware acceleration for this PyTorch thing. You see everything worked. I'll put, by the way, all of the links down in the video description. So yeah, go in there while you're at it. Leave a like, leave a comment. And of course, if you want to help me out and become a VIP supporter of the channel, you can buy me a coffee. There's a link in the description. Or you can join my Patreon or join my channel as a member. You guys, you know it. You make all of this possible. Anyway, let's go back. And we can go to the second step of really setting up Siril. So I'm going to close the GPU manager now that we're done. Go back to core, which again is the only thing that should be in there for you. And we're going to go to the Siril catalog installer next. And in here, there's two things that you don't actually have to install because Siril can do its own stuff to basically each time you want to calibrate the colors of an image based on the actual star spectra that for the stars that are in the image. Well, Siril can ask the internet and the internet will come back and say, yeah, this star is supposed to be this color. And then Siril will adjust basically the colors of the image. And there's another thing, like you have an image and you want Siril to understand where it's pointed at so it can actually identify the stars to get the right colors and do other operations as well. It can do the same thing. It can ask the internet will come back. It's just there's always an online connection needed. And it can take time, especially if the remote servers that are doing all of that for free out of the kindness of their hearts, if they're overloaded, can take forever. So instead, we can have everything locally, and that's what this catalog installer does. So this step is not mandatory. You can start everything without that, but I would recommend doing it anyway. So I will click on Install for the Astrometry catalog. And yes, we do want to proceed, so I'm going to say yes. And I'm going to click this little arrow on the right to display the console on the right-hand side, which for you might have been displayed by default. And the progress is actually visible here on the bottom right. You see it's downloading 1.06 gigabytes. That's the small file. SPCC files will require probably a lot more data. And here we go. The Astrometry catalog has been installed successfully. Now we can go into SPCC. Again, remember, this is all optional. But I just like to have everything locally so I can process everything locally without having to, worry about things. Just this, you can just leave it to galaxy season. Just make sure that your observer latitude is roughly correct. For me, I'm 36 degrees north, more or less. My elevation is like at least 10 meters above sea level, let's say. And I'm going to set like visible from latitude and click on install. Now that can download a lot of files. And I think last time I did it, it was something like 15 gigs of data. So that's going to take a long time. Just going to click on install. Again, I get the warning about the large amount of data. Click yes. We're now going to wait until everything is done. So once there's no movement in there, and don't be fooled by the first download that's just 71 megabytes. It's just the first of many. So yeah, I'll see you once it's all done. It might take like 1 hour or two actually. But again, remember, this is optional. This is just for me to have the best possible performance and have everything work offline. And we're done. The SPCC catalog has been installed successfully, so all of that stuff can now basically be fully done offline, which is very nice. Next step is going to be installing a series of scripts that are really adding a lot of power to Siril. So for that, we'll go to scripts, get scripts, and there will be at the bottom a catalog of scripts that are available. Now, there's no real description of what each script actually does. You kind of have to like double click on the script and see whatever notes the developer left towards the top, like the overview. So this is a color grading engine, right? So to get an idea of what it is. What I would suggest to install is all of the Verilux stuff. I don't know that I'll be using them in my tutorials, but yes, actually probably will use the hypermetric stretch, but it's nice to have them. So Verilux stuff, it's in there. I also recommend the image window script as a utility. This basically lets you effectively save your current image, the step that you're on, into a separate window so you can switch back to it whenever you like. And this helps solve one of the issues of Siril compared to PixInsight, which is Siril has only one active image at any given time. And this lets us kind of work around, to some extent, that issue. Now, I would recommend, we installed the parallax stuff from Cycon. This is going to let us deblur images effectively. So I'm not sure if Cycon Studio is going to work, but let's put Cycon Studio and parallax, StarNet as well to remove stars. I will myself add those 3 scripts because I own the RC Astro tools, but those are paid tools, so we're not going to use them in this tutorial. If you have RC Astro, though, you definitely want to install those scripts. I'll add the statistical stretch, which is also very nice to have. And then there's a script that I added to Siril, actually, taking inspiration from another script from PixInsight. It's basically a port of a PixInsight script to Siril, narrowband normalization. So if you're going to do especially one-shot color narrowband, but also even like normal narrowband, this is very useful to achieve a proper Hubble palette. I recommend HDR multi-scale transform. It can be useful for things like the Orion Nebula. Graxpert AI, that's going to be used by us to remove gradients from the image. I like having those 2 star reduction tools. This is towards the end of the workflow. If we have a very nice nebulosity area, sometimes the stars can distract from the nebulosity and we can make them smaller with those scripts. DB extract can be nice for merging one-shot color data where you have both H-alpha oxygen 3 and then oxygen 3 sulfur 2 separately. So if you're going to go like full narrowband, you can use that, but if you have just a smart telescope, you don't really need it. I would recommend Cosmic Clarity Native. That can be an alternative to parallax. I probably won't be using it in this tutorial, but it's something that you can play around with. Auto gradient removal, auto background extraction can be nice to have as well. Then there's another script that I added to Siril, which is called Astro Color Mixer. This is a very powerful script for both normal color images, but also narrowband images. Both very useful for smart telescopes because smart telescopes then can typically do both with the light pollution filter, for instance. So I highly recommend it, and I'll be using it in this tutorial. And then the aberration removal as well. Now in here, I want to add another script, which is going to be another port from PixInsight called Lighthouse. But Lighthouse is currently waiting for the lead developer, Siril, to merge it into those repositories, so it's not directly available in here. If it is, just search for our Lighthouse, it should appear. Otherwise, we'll install it manually, and I'll show you how to do that. Then we have the pre-processing stuff, which is to stack images manually. So if you have a Seestar, for instance, and you want to do some stacking of Seestar files, you have this guy here. Or you have the Astronomy Smart Telescope script here. And you even have a Seestar Mosaic pre-processing. So you can use that as well. I personally like to just use whatever the stacks the Seestar made within itself, especially when we can do like the super deep stacks where you can have the Seestar basically stack everything, and so we don't need to do it manually, but this is all available as part of scripts if you want to use them. There's something a bit weird in this list in that there's a critical script that we're going to use that, as far as I can tell, doesn't directly appear in the script, or I just missed it. Let me know if I missed it. But yeah, if you search for AMSP, it should come up. And there it is, AMSP, and we're going to use that for stacking if we ever need to use that for stacking. This is basically Siril's answer to the PixInsight weighted batch preprocessing. So this is a library of tools that are completely free, most of them, that we can use as part of Siril, and they really expand the functionality of Siril. And now that we've added them, we have access to all of those tools here. Now let's add manually my Lighthouse script. Hopefully, by the time this video is released, we might have it directly installable from the screen we just looked at. But otherwise, if it's not the case, just go to my Siril scripts repository, select the Lighthouse script branch in here, and then under processing, there will be lighthouse.py. So I'm gonna click on that, click on the download button to download this file, lighthouse.py. And then under Siril, I'm gonna go to get scripts and verify which are the directories in which I can place some scripts. One of them is this directory here, so I'm just gonna select and Control-C to copy. And then from the File Explorer, I'm going to put lighthouse.py in this folder. Then in here, I'm going to click the refresh button effectively, click apply, and now I should have under Python scripts a new scripts area with Lighthouse in there. So that's how you can also install scripts manually when you don't have them available directly in the repositories. So that's all the setup really that you need for Siril, and now it's time to have fun by processing images. The first image I'm going to process is a more advanced image, and it's actually going to come directly from the Siril book. Towards the last chapter, the chapter before last, has a series of detailed processing examples and with the data that you can download as well, including like the non-stacked data. So it's really a full tutorial. There's multiple examples. I'm going to go through one of them, and that's relevant both if you're doing monochrome LRGB imaging, and then once we've combined the images, it's relevant if you're using a smart telescope on galaxies, so broadband. And after that, I'll be showing how to process as well the output of a smart telescope on a nebula, so the North American nebula, and how we can process that using basically a dual band kind of technique to have the nice Hubble colors based on that, using all of the scripts that we've added. So let's get to it. Again, I'll be following basically for the first example what this tells me to do. I'll be skipping a few steps here and there so that I don't reveal all of the secrets that are in this book. I mean, I'd feel bad if I did that. Let's get to it. And I'll have chapters, by the way, down below so that if you're a smart telescope user, you know where to skip ahead to basically see how to make things work for your Seestar or your Dwarf Mini, for instance. So for this particular example, we're going to start with the unstacked LRGB separate stuff. We're going to stack them. We're going to combine the colors. We are going to end up with a color image. And that's where, if you're a Seestar user, you want to join us back because then the process is exactly the same as for a standard Seestar image. So let's get started. The very first step when you use Siril is to set your home directory. This is where Siril will put any intermediate files that it creates, save anything like if you remove the stars using StarNet, it's going to save the star image, the star mask, in that directory. It is the home directory. So you can see for this time, I have it set to a folder back when I was testing the Vespera 3. This time I'm going to set it as Siril, and we're going to actually process Thor's helmet, so NGC 2359, and I've created already a process folder, so I'm going to set that as my home directory. So it's good to do it before every time before you process an image. That way you know that everything is going to be nice and neat under a single directory. Highly recommended. Okay, so let me show you how this image data looks like. Okay, so let me show you what this image data looks like. We have dark frames, we have flat frames, we have lights, and we have bias frames, also known as offset frames. So we have all of the frames that we need. I won't be able to share this data directly because, again, I don't really want to like step on Siril's own book, right? But later in the video, I'll show you like data with a one-shot color image in broadband, and we'll be able to play through that as well. And I'll be sharing that data so you can play along. So first things first, we're going to go to scripts and pre-processing AMSP, the script that we just installed earlier. And what I'm going to do is one by one, I'm going to go to my folders and I'm going to put my lights. And there you see, it has detected the lights and each night that they were taken on directly. I'm going to put my flats in there. And you can see it detected the flats. It even has separate flats for each of the nights. So the script is actually going to be smart and it's going to map the flats from that night to the lights of that night, etc. So that's pretty nice. And then we have offset files, so the bias frames. I'm gonna put them there and you can see that there is something wrong there. You can see it thinks those are light frames. This is because the original data was probably not taken that carefully, and so the incorrect metadata was put into the raw files. And when Siril reads that, it thinks it's light frames. Fortunately, I prototyped a change to the script, which is written by Siril, the main developer of Siril these days. And after prototyping that, I was able to convince him to add it to his own script. So now, and thank you Siril for doing that, now you can go ahead and right click and say force as bias. Bam. And now you can see that under calibration, we do have the offset files set as bias. So that's quite important, right? Otherwise, we'd be in trouble. If your light frames and your flat frames, etc., are properly taken, then you don't need to worry about that. If you're using a smart telescope and you're stacking yourself, well, anyway, the smart telescope typically gives you only light frames. The Seestar will automatically have them calibrated with dark frames, so you wouldn't really run into this issue. Let's add the dark frames now. And you can see we have the exact same problem with the dark frames. They're misidentified as light frames. So I'm going to right click and say force as dark. And now we have everything ready. And yeah, there we go. So now we can actually select an output directory. By default, it's going to be the home directory, which works. So we can use that. And we can look also in the gear icon to see exactly what we want to do. There's several things we can do, like a background extraction per file so that we get fewer gradients in the final image. It takes longer. We can do a distortion correction, which is going to plate solve each file in addition to just matching the stars to one another, and that makes the stacking even better. That's actually really nice. You can use the nearest flats. That's what I'm going to do. And we're going to save the masters. We could also do a drizzle integration if we wanted to get even more resolution. For now, I'm not going to bother, but you can see we have all of the nice options. By the way, if you don't know what a drizzle integration is, it basically increases the resolution of your image at the cost of additional noise. And it's only possible if your frames have been dithered, meaning there's been some small movements in between your subframes. It's done automatically by most smart telescopes. So I'm just going to say OK, and we're going to start the pre-processing. And you can see on the right-hand side, it started working, and it's actually quite fast. So it's going to take a few minutes, and I'll see you back once it's done. Okay, the process is complete. It was actually remarkably fast. And if I go to the process folder, we can see that we have the raw master frames for red LGB, and we also have the aligned master frames for LRGB, right? So that's all well and good. So it means they are aligned to one another, but because I know there are stacking artifacts, they always are, I want to make sure that I crop all of them together. In PixInsight, I would just open them all and then apply the same crop process to all of them. In Siril, what I need to do is go to composition under image processing and RGB compositing. Yes, I want to close the current image. It's just a remnant of the stacking process. click on yes, and I make sure that use luminance is on, and I will select the luminance file. Red is going to be red, green is going to be green, and blue is going to be blue. Now the image that is shown doesn't look like anything, so we want to go into this little thing here, which is just a display thing. It doesn't apply anything to the image, but if I click on auto stretch and then I unselect this button there, I can start to see what's going on. And that's because now we have an unlinked auto stretch on the image, just on the display, which means that each color channel is being stretched separately before being merged. So we are a bit better able to see what's going on. And what I want to do really with that crop is crop all of those 4 images together. So I would expect to be able to do crop and then crop sequence. For whatever reason, it is grayed out until I click on align here, even though there's no need to do any alignment. And now crop sequence becomes available. I think it's a bit of a bug, but whatever. I'm going to click on crop sequence. And now that it's done, I will click the Save All button to really save my 4 channels there with the same crop. And that's going to be quite important because with LRGB images from monochrome cameras, I need to process the RGB, the color part, and the L, the luminance part, separately, because then I need to join them after we've done the actual stretch of the image. So I'm just going to save all. And if we look at the working folder, we see that there's a new set of images with comp aligned, etc. So now I'm going to clear completely the image compositing, and I'm going to select red, green, and blue only, because those are the only ones that I want to process right now. We're going to do luminance separately a bit later. We still have the auto stretch enabled, and it's also unlinked. So now we can do the fun stuff, which is first we need to remove the background of the image. The easiest way to do that is to go to Python scripts, processing, and Grexpert AI. There's also AutoBGE that works pretty well, but Grexpert AI works in most cases. I'll leave the smoothing parameters as this. That said, if you're too aggressive with the smoothing, it might actually remove some nebulosity by thinking it is background. So actually I like having higher values of smoothing, all the way to 1 actually. Click on apply and let's see what's going on. It seems to be quite nice, so I'm fine with this smoothing of 1. And we suddenly can see the image a bit better because that yellowish background is gone. Now if I link the channels again, you can see that we no longer have that yellow color all across the image. So that's exactly what we wanted. So now what I can do is I will go to Tools, Astrometry, and Image Plate Solver. This is going to allow Siril to know exactly what we're looking at on this image so that it knows what star is what stars, and then it will be able to compare the star colors to a catalog of their spectrograms and thus adjust the colors of the image to be true to life effectively. And here everything has been pre-filled because the data is within the fit file. So the target coordinates as well as the focal length and the pixel size are pre-filled. And if I click OK, it's just going to work as is. The next image we process, also going to be a quick LRGB, will not be that easy. But yeah, just quickly showing you that. And now that Siril knows which stars is which, really, because it knows exactly now where we are pointed to in the sky, we can go to image processing, color calibration, spectrophotometric color calibration. And this is indeed a monochrome camera. The sensor was the 455, so it's the correct sensor that's been selected. Otherwise, you can just go for a generic sensor if you don't have it in your list. And the filters that were used were actually chroma, red, green, and blue. So I'm just going to keep those here and click on OK. And you can see we have a nice white balance summary. If you see the points on the graph, on the line, it means it's a good thing. So I'm going to close that. Click on OK. Click on Close. And here we go. The image is now properly color calibrated. So now what I can do is do an operation called deconvolution that basically deblurs the image. And we're going to use Scicon that we downloaded earlier. So I'm going to go to Scicon and click on parallax.py. Once it's open, the first thing you want to go do is go to Models. Make sure that you select the model files that we downloaded. So you click on Select Model Files, go to the folder where you saved the model files, select them all, click Open, and there they go. They are now all installed and ready to go. Under Advanced, make sure that you have Apply Temporary Stretch that's clicked, otherwise you won't see much, and that you have an unlinked stretch because we want to preserve the star color since we did the star calibration. The default stretch might not be strong enough. It might have been something like this or even less, something like this. And I want Scicon to have access to more data, so I am increasing intentionally the amount of stretch that we're doing to the image before the deconvolution, and then it will go back to linear automatically. You can have a preview ROI and run the process just on that preview rectangle and see the before and after. It's quite subtle, but there's definitely a bit of a difference. This particular example is one where we could actually increase the nebula de blur quite a lot, to a point that it gives us a warning, like, are you sure you want to do that? And we can even increase the star sharpening as well. Let's process the ROI again, and we can see before after is a bit more pronounced than before. So now I want to run it on the full image. This will take a little bit of time. By the way, for me, with my AMD GPU, for whatever reason, the first time I did this, the whole image was lost, and so I had to force CPU execution. So if you have any issues, you just click on Force CPU execution. And it's done. We can see the before and after in the preview. Don't close it. Don't forget to click Apply to Siril, otherwise the work gets lost. So now it's applied to Siril, and I can undo and redo. And there is definitely a large difference. One more thing we can try to do is go under Python scripts, processing, and do aberration remover, which is also an AI-based tool that corrects only the stars. You'll want to click first on download model and info, because for me it's already installed, I don't need to do it, but just click on it, wait for it to download, and then you can just click on calculate. There we go, it's done. And if I go before and after, you can see there's a fairly large difference in the stars. Okay, pretty nice. So now we need to stretch the image. And in the book, it explains super well under image processing, stretches, and generalized hyperbolic stretch transformation. This is something that everyone swore by so much, and I just could never get it to work, whether in PixInsight or in Siril. This book made it easy to understand. I'm not going to go through it in this video. We're going to go the lazy way, but it can be better actually with the GHS transformation. So I highly recommend you learn it. In this video, we're going to say simple. We're going to go to scripts, Python scripts, Verilux, and we're going to go for the hypermetric stretch from Verilux. So there we go. And in here, it's pretty simple. Just make sure you have the right sensor in there, or just Rec 709, AutoCalc log D, and process. That's it. Now I'll make sure also that you go back to linear to see exactly what happened. And there's the result of the process. Simple enough. We're really close to what we want. Okay, so now we have RGB image that's stretched. We want to add the luminance to it, right? Let's not forget about the luminance. So I'm going to save the image using this little Save As button. We're going to save it as RGB composition. Click on Save. We're going to keep the default settings. Click on Save again. And just for the heck of it, I'm going to keep a copy of this image using utility image window that we installed earlier. And basically that means that now I have this image lives in the main window right now, but also in a secondary window, and I can always copy it back to Siril whenever I want. It's just, it's a good safety measure to have. But anyway, I'm going to now open the luminance file. So for that, I want to use this guy, the one that we did the crop sequence on. So the one with the prefix comp. So I'm gonna drag and drop onto Siril, say open, and we need to start from scratch, right? We need to do the auto stretch. So what we'll need to do is the background extraction, just like before. So now we're going to run exactly the same processes. Boom, apply, done. Then we want to do, there's no color calibration to do, so we can directly go to Cycon and parallax. I'm just immediately going to run the full image. It's done. We can look at the before after and apply to scale just like before. I'm again going to go through the aberration remover as well, because why not? And now we're gonna stretch. Oh, by the way, there is one step that we could have done at the color level before stretching. We can do it after stretching as well, so it's not gonna be a big deal, but it's denoising. I'm gonna do it on the luminance just to show you what it looks like. Go under scripts, Python scripts, processing, Graxpert AI again, except that now we're gonna choose denoising. I'm gonna put like 0.8 at the strength, apply, okay, and now you can see that if I do a before and after, the background is much smoother before and after, and we haven't really lost lots of details. So that's just something we could have done to RGB as well, and maybe I'll just do it actually afterwards. Let's now stretch the image. So going to Veralux, hypermetric stretch, AutoCalc process, the easy way, right? And linear, close. And now I'm going to save this image and put luminance for composition. Okay. Okay, we have RGB and we have luminance, but actually the RGB composition tool requires, so if I go back there and I close the image, it requires separate frames for RG and B, right? So I'm going to reopen, or I could just use the image window that we had earlier. So I'm just going to copy the image to Siril. I could just have open from the fit file. Hey, maybe I'll run Graxpert now, Graxpert denoise. Ideally, I should have done it on the linear data, but it doesn't really matter that much. So I'm gonna run Graxpert denoise on the RGB image as well. Bam, and now, so yeah, we can see the before and after. A lot of the noise has been smoothed out. And now I can go and actually go to image processing, channel extraction, and split channel. And here I'm going to say red, green, blue as the names. When I click on apply, if I go back to our home folder, we have the RG and B images that have been saved in here. So now we are ready to go to image processing, composition, RGB composition. I'm going to close the image. And I'm going to set luminance. We're going to use the luminance, and then red, green, and blue. And everything is already aligned because we cropped everything together. And so now we can see the difference between not using luminance and using luminance, right? That's where we can see the main difference of using luminance. And we can also choose how we want to add luminance to the image. And we can choose whichever we prefer. And I like this one, right? So I'm just going to close. And now we can keep working on this particular image. Now, obviously, to me, this image looks very close to complete. We can do a couple of other things if we want to. We could first remove the stars. We'll place them back later on so that we can process just the nebulosity. So I'm going to go to image processing, star processing, StarNet removal, because we installed StarNet earlier. We don't need to pre-stretch the image because it's not linear, but we do want to make sure we generate a star mask so that we can replace the stars in the image later on. And I am going to click on execute, and it's done. So now the stars have been removed. If I look into our working folder, we have starless and star mask. Both have been saved. So there we go. And now I can play with stuff. I could say, okay, we're going to use my Lighthouse script. So if you installed it manually, it's under script. If it's available on the repo and you installed it from the repo, it's going to be under processing. And on the scripts, I'm just going to click on Lighthouse. Up there we have the entire image, and I can play with stuff like contrast directly, and we can see the result on the image. I can play with brightness in general and exposure as well. And some of the cool stuff as well is to play with stuff like clarity. So you see clarity actually really increases the amount of the sharpening on all of that. How sharp things are becoming, maybe too sharp. And you can also play with vibrance to make the colors more vibrant, as the name would imply. Now, when we do that, it also affects the background of the image. So if we want to apply that only to a given mask, we could enable a luminosity mask, and we want to target only the bright areas, right? So we can show the original before and after, and you can see there's only the bright areas are being targeted. And now I can apply, and Lighthouse has been applied. We can see the before and after. And I could go actually again to Lighthouse, because we could apply a second round if we wanted to, because the mask can be really strong, and so we don't get as much as we would expect. So I could go back to enabling the mask. We're going to protect the darks only, and we're going to apply some more clarity. There we go. We're going to apply some more vibrance, something like that, and maybe some more contrast. There we go. That looks nice. And we can apply again. I'm going to, and we can actually apply in a row if we wanted to, like apply. And let's say that in the end, I end up with this image, right? After applying a Lighthouse script multiple times. We could also play with curves. So there's a curve tool as well. It's something I like to do. You could apply a kind of an S-curve to the image to increase really the contrast. Make sure you're not too aggressive. And we can look at the before and after by using the preview button there. I think I'm too aggressive actually. But yeah, this gives you an idea of what's possible. Click on apply, close, and now we have like this nice contrasty image, and we're now ready to put the stars back in. And so to put the stars back in, we're gonna simply go to image processing, star processing, and actually first I need to save this image. So I'm gonna save the image as starless processed. Okay, it's now saved. And now I can go to image processing, star processing, and star recomposition. And in there I can choose my background as a file, which is that starless processed image we just did. And then the stars themselves, they're the star mask there. And bam, we are just like that, replacing the stars in the image. We can further do some processing. For instance, I want to remove or like diminish the size of the stars. For that, first I need to save as a fit file again. So I'm going to put star full as the name and save. And now I should be able to go to scripts, processing, build star reduction, and I highly recommend using the star mode here. Moderate works well usually. Click on apply, and in the background this will apply another round of star nets, remove the stars, diminish the stars, and place them back actually. And there we go, we have the image with the stars reduced. It's kind of like my final image. I think I went too strong on the contrast, etc. But you get the spirit about what is possible with Siril. And then I can just save as a JPEG file if I want and share it, etc. So that's one example on an LRGB file. I have another example where we can follow around, because I'm providing you the data. Again, the link is going to be in the description. And for that, I have this PixInsight 0 to hero raw frames, except now it's being used in Siril. I created an M101 process because that's the next image we're going to process. M101, we have already 4 files that have been stacked. So we don't need to do the stack at all, but we actually need to convert them to fit file, because while I can open them individually in Siril, I cannot use the RGB compositing tool without fit files. So for that, there's actually a conversion tool in Siril. So I'm just going to go to this conversion tab here, click the plus button, go to my M101 folder, select all 4 files. We're going to set a name of the sequence is M101, but we don't click convert yet because, remember, we need to set the home directory. I don't want to put that in the ngc2359 process, so we're going to go to this M101 process as our working folder. Now we can click convert, and if I go to our working folder, here it is, we can see that we have now 4 fit files, except that they don't have RGBL in them. So I'm going to open this little conversion file here that tells me that 1 is blue, 2 is green, 3 is L, 4 is red. So I'm going to manually rename, which is a bit painful, but it is what it is. So 1 is B, and I can do all of the others. So 2 is G, and etc. Okay, they're renamed, and now we can go into image processing, composition, RGB composition. I'm going to click on clear just so that we are nice and clear, and I'm going to open everything just like before. L, R, G, and B. Okay, and here I'm running into an issue with RGB composition. That actually, like you see, the image stays on the black and white. I cannot play with linear, and I have no idea how to fix that really, unless I restart Siril. So that's what I'm going to do. I'm just going to close this, close Siril, and I've restarted it. And now if I go to composition, RGB compositing, I'll get the luminance file, I'll get the red file, I'll get the green file, I'll get the blue file. And now it's all working. Let me know if in the comments if you have a workaround for that. So now I can actually select this auto stretch, do it unlinked, just like we did before, so we can see what we're doing. And I'm going to do a fairly aggressive crop just on the galaxy because that's what interests me. And just like before, I'm going to right-click, crop. Crop sequence is not available until I go back to here and click on align. So now I can go back to crop and click on crop sequence. There we go. And then save all. Now we've saved all of those comp files. If I go back to my process folders, bam, there they are. That's exactly what we need. And I'm going to clear everything and now reload the comp R, G, and B. Bam, just like we did with the previous image. And now we can process this. So we're on Rails, just like before. I'm going to go to Graxpert AI, run the background extraction with a smoothing of 1. I can do some deconvolution. So I'm going to go to Cycon Parallax. No, wait, actually, I want to first do color calibration. So I'm going to go to Tools, Astrometry, Image Plate Solver. And you can see I got the coordinates from the image. If not, you can put the name of the target and click find, and it will suggest coordinates to you. But you can see my pixel size is incorrect, and I was using an IMX571 sensor, so I know it's actually 3.76. So by setting that and clicking OK, bam, astrometry is successful. With 5, it wasn't successful. So that's the kind of stuff we need to be careful about. And now that we are plate solved, I can go to color calibration, spectrophotometric color calibration, except that now we are in one-shot color mode. It is indeed an IMX571 with a UV-IR block filter. And I'm going to click on OK, and we get nice straight lines with the stars along those straight lines. So I'm going to close, and we are now going to link our channels again, and this is our real colors. Now I can go to Cycon, do the deconvolution, which is going to deblur the image. For this one, we need to go lower, like something like 0.79. And I'm going to just run on the full image because the stretch in here happens to be pretty nice. I'm going to maybe diminish it a little bit like that and run on the full image. We can see the before and after. There's a real difference, especially on the stars and to some extent on the galaxy itself. So I'm going to apply to Siril. We can run just like before the aberration remover, okay, to get even better stars. And now we can do some denoising, the one that I had forgotten previously. So I'm going to go to Graxpert AI again, go to the denoising, put it fairly strong, apply. It's done, and you can see that suddenly the image is, the auto stretch went into overdrive, and this is because when we denoise an image, auto stretch has more room to breathe, and then it tends to overemphasize what was stretched. So it's very difficult to actually compare the before and after of a denoising operation on Siril. In PixInsight, it's not a problem because the auto stretch stays the same until you manually rerun it. Siril does it automatically. In version 1.5, the next version, there's going to be a way to keep the auto stretch as is until we rerun it. But at this stage, it's not the case. So unfortunately, we have to live with that. And now I can go ahead and stretch the image using the hypermetric stretch. Again, I'm going to be very abrupt about it. Look at it from the linear mode. This is exactly what I want, looking nice. And I can save. No, wait. Actually, I'm going to directly go into channel extraction, split the channel, and save them as red, green, and blue. And apply. Now we have our red, green, and blue stretched channels that are available to us in our process folder. There they are. So now we can do exactly the same, but for the luminance. So just like before, just for the heck of it, I'm going to go to scripts and utility and keep that image as a separate image window, just for the heck of it. And now I'm going to open the luminance file, which is this guy here. And we're going to go back to auto stretch, and we're on Rails. We're going to do Graxpert, background extraction. Here we go. We can do the deconvolution because there's no need to do the color calibration, obviously. So Cycon parallax. I'm going to run this directly. And there we go. Apply to Siril. We can see the before and after. There's a clear difference. And I can further use the aberration remover. There we go. And we can stretch the image now. So same story, Veralux, the hypermetric stretch. Of course, if you did it manually, you would get better results. But, you know, we're being dirty here. This is how it looks like, or what it looks like in linear mode. So now I can save this as l.fit. Bam. There we go, saved. And so now we are ready for the final composition. So RGB compositing. I'm going to close the current image, use luminance, and we're going to use L, R, G, and B. Bam. And you can see use luminance or not. So there's a big difference there, and the luminance doesn't look like it's actually helping a lot. I don't like it with the luminance. So maybe my luminance channel is garbage. Can happen. Let's see with the other compositions. Right, so I don't like it. So we're not going to do that. We're just going to keep the RGB image, and what we did for luminance was useless. It is what it is, I guess. That can happen, apparently. And now we can process from this image. So we could do exactly like last time. We can simply remove the stars and place them back. So star processing, we're going to do starnet removal. No need to pre-stretch the image. Click on execute. Now we could go to Lighthouse script again, and we could do some, the usual, right, the contrast. Let me fit to the image. And you can see I've increased vibrance, I've increased clarity, I've increased the contrast, and this is a nice and punchy image. I'm going to apply it to Siril. There we go. And this is pretty nice, actually. I think we can place back the stars just like before, so I need to save this image as starless. Bam. Save. Now we can go to star processing and star recomposition, and I'm going to select starless that fit and the star mask from before. There it is. And now we're placing back the stars. I can click close, and just like before, I can save that as a fit file, so star full. Bum. And now that I've saved it as a fit file, I could probably reduce the star size using Bill star reduction. apply it. It's going to run StarNet on it. And there it is. We have the image with the stars reduced. It's really looking at the galaxy itself. Obviously, this is taken from Tokyo, so it's not the best image ever, but this is a good reference of how to do this kind of LRGB composition. So next step is just a one-shot color image, just like what you would get out of a smart telescope on a broadband target like the Pleiades or a galaxy. And we're actually going to use the Pleiades. So let me show you the Pleiades. So it's still in the same set of data. I'm going to create a new folder called Pleiades Process. And I'm going to change the home folder to Pleiades Process. And now we're going to do exactly the same kind of stuff we did before. I'm just going to open up the main Pleiades image, except that now, instead of having to combine channels, we can just process directly. So auto stretch, unlinked, now we can see what's going on. We have stacking artifacts, so we can do a crop. I'm going to do a selection like this, and then right click, crop, crop, crop. No need to crop sequence anymore because this is a single image. Now we're cropped, I can run Grexpert. So processing, Grexpert AI. We're going to do the full smoothing, apply. Grexpert has been run and suddenly the Pleiades are looking a lot sexier than before. So now we can do some astrometry to be able to do some color calibration. This tool's astrometry image plate solver will let Siril know exactly what's going on. And it got the metadata from the image, so it knows the correct focal length, pixel size, and coordinates. So I'm just going to click on OK, and you can see it worked immediately. Now we can do some color calibration, spectrophotometric color calibration. It's one-shot color. On IMX 571 is a UVIR block cut filter. Click on OK, and we have nice stars along lines. This is exactly what we want. Close, and now I can link the stretch, and nice. We have these nice blue colors. There's quite a bit of green in the background, so what I'm going to further do is go to image processing, remove green noise, only do it when it's necessary. I'm going to select average neutral, and there we go. I like what this looks like. And now we can do the usual, the deconvolution, using Cycon Parallax with its free model. So let's try a preview, look at processing the ROI just to see what we would get with our current settings. Actually, it's a nice little result. I might increase the impact on nebulosity, process the ROI again. Yeah, and I kind of like what I see, so I'm going to run it on the full image. And it's done. I'm going to apply to Siril. And now we can see the before and after. It's a nice difference overall. I can run my aberration remover script as before. I mean, it's not my script, but the aberration remover script. Okay, we're good. And now we can denoise things a little bit. So I'm going to go to Grexpert AI, run some denoising. Bam. There we go. Fairly aggressive. I'm going to click on apply. Here we go. It's nice and smooth. And now what we can do is stretch. So again, script. We're going to go to Veralux, hypermetric stretch, AutoCalc log D, and process. Now I'm going to go back to linear, and this is what we're getting. I mean, it looks very, very nice already. And if I want to, I could, let's try it. Remove the stars, process a bit the image, and then put the stars back, right? So just like before, image processing, StarNet removal. We don't need to pre-stretch the image because it's already stretched. we're just going to generate a star mask. There we go. It feels weird to see the Pleiades without stars. But now we can process this particular image, right? And I kind of want to desaturate a bit the background. I feel this like reddish color is kind of distracting. So I'm going to use another script, which is one that I added actually to Siril, which is the Astro color mixer. I don't know if it's going to be successful, but in here, maybe I can try to go to saturation. And here what I can do is that I can amend everything per color effectively. So I could go to my saturation and say, I want to desaturate red. Orange is the same, yellow is the same. Well, blue, I want to actually increase the saturation on blue. So let's do it. Magenta, I want to decrease. Purple, I want to decrease a little bit. And let's see, show original. And you look before the original and the new one, we're desaturating the background and saturating the foreground. This is exactly what I wanted. So that's perfect. I can just apply to Siril. By the way, the color mixer script is extremely powerful. So I have a video on that topic. I'll put the link down in the description if you're interested in learning more about this script. There it is. So we have the before and after, much less red in the background. And I could do a little bit of lighthouse script again. So I'm going to go to my lighthouse script here, into the center, and I like using some clarity without going hopefully too much overboard. I think this is going a bit overboard. Something like this. So this is before and after, and some vibrance in the colors. Before and after, a bit too vibrant actually, but you see the feeling. And maybe some contrast. Before, after, nice and contrasty. I kind of like that. We could brighten the overall image as well, or not, as we wish. And I'm going to just apply that. Applied, so we have the before and after. But you can see now we're just playing around. And again, we could do a curve if we wanted to. So I could go to image processing, stretches, curves transformation, and do some kind of like S-curve on the image to increase the contrast like this. That's actually not too bad, right? A very light S-curve like that I can apply to the image. And maybe we're good like that. So I'm going to save that as a fit file. So I'm going to call it like starless. Yeah, just starless is fine. Save that, and now we can go to the star processing, star recomposition, and I can select my starless image, my star mask from before. Now we have everything. I can save that as a fit file, so we can put it starful. There we go, save it. And I can diminish the star sizes. Actually, what I'm going to do is I'm going to use a script, Python scripts, utility and image window to copy this current image into the image window, because the star reduction script actually doesn't allow undo. And that's something that I wish there was an easier way to know before running the scripts. And so in order to be able to do the before-after comparison, I'm using this. So you'll see what I mean by, for me, I'm going to use processing, build star reduction, go to star and click on apply. And it's done. The undo button is not available, so I can go to my little image window and swap it with Siril to see the before and after. Before, after. And I really like the after actually. So that's really nice. And we have basically my final image for now of the Pleiades using only free software, right? And retaining full control throughout the process. So I really like that. And now we can just save it as a JPEG, as a fit file, etc. We are done with this image. So we can go to the next one, which is going to be one-shot color, but H-alpha oxygen 3, which is exactly what you get if you use your Seestar with a lot of emission nebulae? It does it automatically, where it sets the light pollution filter. And the light pollution filter in the Seestar is actually taking hydrogen alpha and oxygen 3 band passes from the nebulae, and we can use that. So for that, I'm going to go back in here, in again the data that's available to you to follow along. I'm going to create a new folder that's going to be NA nebula, or just NA process. And that's going to be my home folder. We are going to process the North America nebula. So for that, first thing first is always the home folder. I'm going to go to the home folder and select my North America process, click on open, and now I can actually open the raw file, which is this guy here. And let's do the usual auto stretch, unlinked, to see what's going on. And this is the image that we have of the North America nebula. So now you can see you have all of this red pinkish color, which is very nice, and that's because most of the nebula is overactive with hydrogen atoms that are emitting in the deep red. That's why it appears red-pink on those images. And we are going to also show that this nebula at its center around here has some oxygen atoms floating around that emit light in the blue spectrum. So we'll be able to reveal that via this processing, which can be quite hard traditionally, but with the narrowband normalization script that I added to Siril, it should be relatively easy. So let's get to it. And by the way, you can get extremely similar data from your Seestar, from your Dwarf telescope, from your Vespera telescope, and process it in exactly the same way to achieve similar results. So let's go through the process just like before. There doesn't seem to be any obvious, there are cropping artifacts at the bottom. So what I'm going to do is, as usual, we're going to do an initial crop of the image, something like that. Right click, crop, crop. There we go. And now I want to do my background extraction. So I'm going to go to Scripts, Processing, Graxpert AI, and I'm going to have a smoothing of 1, Apply. Now that the background is extracted, we can see there's going to be an interesting difference between the linked auto stretch and unlinked auto stretch. And I'm going to prefer the unlinked auto stretch for this image because you can see the center of the nebula, where I know the oxygen 3 is already a very different color from the rest of the nebula. Whereas if we link the auto stretch, you can see that everything is pink, and recovering the blue in the center will become more difficult in the end. Now, it might not always be the case for all images, so you may have to play around depending on your image. This is where things are a bit iffy. At least for this image, I would recommend going with an unlinked auto stretch just to see what's going on. And then we can do the rest of the processing. Now, by the way, this image is drizzled. And if we were using the RC Astro deconvolution plugin, so blur exterminator, this would be quite important to do it on the full resolution drizzled image, which is a huge resolution. And then we could, if we wanted to, sample down to the normal sensor size, basically keeping the resolution, the details that we got from blur exterminator, while also recovering some signal to noise ratio. So really like having your cake and eat it too type of deal. I've noticed that with Cycon, the free version at least, being drizzled or not didn't make much of a difference when applying the deconvolution. So I will immediately go inside like the image geometry. We're going to resample, and we're going to resample by 50%. Bam, there we go. Where we sampled, this will make the rest of the processing much faster, and we've also recovered some signal to noise ratio. So now I can go ahead and go to the usual Cycon parallax. We're basically always doing the same thing, except that we're really able to control each step very clearly, right? So we do want a temporary stretch. The stretch, I will choose it to be unlinked so that it will basically use something similar to what we have. And I will increase the amount of stretching so we can know that the AI tool is having a good view of what we're trying to do. And I've seen that these parameters here work fairly well for this image, so I'm going to run it on the full image and see once it's done. And we are done, so I'm going to apply this to Siril, just like before. Let's have a look at the before and after. So this is before, and this is after. And there's a clear difference both in the dark nebulosity and in the star shapes. And so next step is going to be some noise reduction, so Graxpert AI. And I've noticed that for this image, we don't want to be too aggressive about the noise reduction. So again, this may depend on the image. And a good balance was actually 0.5 on this one. So I'm going to apply that. And some of the things that I'm looking for when doing that is making sure that while there is less noise, so if I look at before and after, there is indeed less noise, but also making sure that the details haven't been eaten up by the noise reduction. And it doesn't appear to be the case right now. So now again, we're ready basically to stretch the image. But let's compare again the linked auto stretch from the unlinked auto stretch. You can see the unlinked already gives us that almost blue color in the middle, so that's what I'm going to use. And for that, actually, I'm going to go and use the statistical stretch because the statistical stretch lets me use an unlinked stretch, and that's what it does by default. I'm going to put 0.2 as the target median, and then just click on preview. And yes, this is what I want. And compared to the standard stretch, like the Veralux stretch that we've been using up to now, this one lets us be unlinked. And so that's what I'm using this time. So I'm just going to apply this to Siril. And it is applied, going back to linear mode. And yeah, that's the kind of stuff that I want. Next step is going to be removing the stars, because now we're going to play with the colors of the nebula. So let's go ahead. So I'm going to go to star processing, starnet removal, and the image is already stretched. So I'm just going to generate the star mask. There we go. And now we're going to use the secret sauce to really get those narrowband colors popping, hopefully. So I'm going to go to scripts and processing, and then that's another script that I ported from PixInsight to Siril. It's narrowband normalization. And look at that. Immediately, you can see that it's in HOO mode, which is exactly what we need for any telescope that is using an H-alpha oxygen 2 filter with a one-shot color sensor, or with a Seestar, for instance, or Dwarf 3 using the light pollution filter that is also effectively H-alpha and oxygen 3. So we want to use that. And then we can also boost the oxygen 3 even more to have like even more blue. But notice that as I play with the oxygen 3 boost, we're also kind of drowning out the yellowish areas. So I want to be careful about that. One way is to boost a little bit, and also we could use the lightness from H-alpha. You can see that it tends to kind of help protect those yellowish type of areas. So that's what I'm going to use. And one of the other parameters we can play with is the blend amount here. And you can see that it can really get the color changing. So I want to go from the default of 6. If I put to 1, it becomes greenish. If I go to like 0.45, it looks pretty nice like that. And I'm going to apply that to the image. So now that we have this, I kind of like the colors. We could actually just increase the saturation and be done with it. So I could go to my scripts, open Lighthouse script, for instance, and just go crazy on the saturation and the vibrance. I mean, let's try it, right? We can play around. That's one of the things with narrowband, is that there's no right or wrong answer. We're trying to show the areas where there's a lot of oxygen 3, even though it's technically drowned out by hydrogen atoms. As you can see, I can go in there and I could increase the saturation, maybe not too much, but a little bit, and the vibrance a little bit, and the clarity a little bit. Actually, maybe a bit too much, but like that, and just, let's apply to Siril. And we could say, like, this is my final image. And for instance, this is the before and this is the after. And this would be, I think, I mean, of course, we need to replace the stars and that kind of stuff, but this would be a satisfactory kind of final image. But let me go back a bit. Let me go back a step and show you what is possible with the Astro Color Mixer script, which we've already used in this video, but we're going to use it in much more detail now. So I am going to make sure to tell it there's no stars and that I don't want to protect low saturation stuff because the entire image is low saturation. I don't want to protect the entire image there. And we're going to select here the custom color range mask. And under mask, we can see its definition here. And let's look at the band mask overlay there. So it is indeed selecting all of those areas with red with the default settings. I can play with the start hue. I can play with the end hue to select more or less. And I can change the mask type. I prefer to go linear because then it's a full mask strength. And I just want to soften the radius there to have a nice blurry mask. Because if the mask is not blurry, then we risk introducing basically chromatic noise to the image. So with that mask in place, we're only going to do changes to that custom color range. And I can go back to luminance. I'm going to look at the adjusted image without the mask anymore. And I can click on the C icon here to open curves transformation. And then I can select different colors. What I like to do is play with the green there with an S curve on the green. And you can see immediately it makes the, you can make one end green/yellow of the spectrum, and the other one, you can make it redder. And here it's getting a bit purplish. We're going to fix that by going to the red curve as well, extending the red curve to make things a bit redder here. And then we can also go to the blue curve and descend it a little bit so we remove that purplish kind of tone that we were getting. And I kind of like the colors that we're starting to get. And there we go. So this is a key for this kind of narrowband image. If we want to have this like gradation between red and yellow and then you go to the blue, that's the kind of stuff that we need to do. It's a bit complex, but you can see it is doable. And then I can play with the saturation of that particular mask. I could say I want to saturate it more, which actually looks kind of nice. So I'm going to do that. I could also play a little bit with the hue to say I want it like, you know, more yellowish. I want it more reddish. Or I could just leave it at the middle. Actually, I have trouble choosing. I like both directions. So I'm just, because I like both, I'm going to leave it at the middle. And now I can just apply this, right? So especially when we're doing curves, the Astro color mixer takes a bit of time. So we'll let it do its thing. There we go. And by the way, if we reapply the process one more time, this is the kind of crazy stuff we'd be getting. I don't want to go that far right now, so I'm going to close the script, and actually we're going to reopen the script. Actually, let me save my work for now. So I'm going to call it Starless Astro ACM1 for Astro Color Mixer 1. That way I have it and save. Okay, so from that point on, we want to play with the blue. We want to make this blue pop out some more, so we need to be able to select it. And so once again, I'm going to run Processing Astro Color Mixer. We need to tell it that there are no stars and we don't need to protect low saturation areas. Otherwise, we'll never be able to select that very low saturation blue. And here I could use actually several masks. I could go to the cyan mask and let me show you what it looks like. There it is. It does select the blue in the center. It selects some other stuff we don't want. So I'm going to go back to a custom color range mask. And let's try to define it so that we only select the blue at the center. And to give you an idea, it's impossible. We've selected, I'm going to put it as linear, we've selected the blue at the center there, but we also selected, you can see the background is kind of blue as well, and we don't want to select that. So what do? Well, we can actually enable a range mask, and we can tell the range mask only select stuff that is light. And all of those bluish areas that are in the background, they're dark. So we're going to enable the range mask, and I'm going to say combine mask here to really see the result. I'm going to say that I want to look at the highlight stuff, and immediately you can see only the brightest blues are visible. I can lower this limit here to make it larger and larger so that we get the blues we want and not the ones we don't. So you can see the mask is not blurred at all, so it is important for me to go back to the custom range mask and get the soften radius there higher. And now we have selected only the blue that we want because we have added both a range mask. You can see the range mask is selecting only the brightest areas. We could almost use it as the blue, as the color mask, and then the band mask selects everything, but the combined mask is exactly what we want. And so I can go to my luminance curves, for instance, go to the custom color range, click on C to play with curves. I make sure that I'm back to adjusted rather than the mask view. And we're going to try, let's say, to get the blue higher. And then immediately you can see the blue pops out. I could say that I want less green to make it more purple, or more green to make it more turquoise, I guess. And let's see what happens with the red. Yeah, we can amend like the blue coloration as we wish. And we can have luminance as well. We can increase it to make it brighter or decrease it to make it more dark and mysterious. And I like actually how it is with the decreasing like that. So we could just validate that, and we can go to the saturation for custom color range and increase the saturation quite a bit. So now the blue is really popping out there, right? This is something that I like. I like how blue the blue is, and it's a big change from the initial image that we had, right? So I'm going to apply to Siril. Again, it takes a bit of time. And here we go. We have this nice demarcation between the blue and the rest of the image. And now what I can do is go to my Lighthouse script to do some more changes. Before doing anything, actually, I'm going to save my image as ACM2. We did the second pass. And in the Lighthouse script, I think I want more contrast. Yeah, I like when it's nice and contrasty like that. We can even decrease the shadows a little bit. Something like that, right? From this to there, like really contrasty. And then the key is going to be the vibrance, some saturation. I think I'm going too far, but you can see I love what I'm doing here. Look at those colors. So show original to there. And one of the things we can do is increase the clarity. I love increasing the clarity. When increasing the clarity to see exactly what we're doing, I'm going to go to one-on-one details so I can have a real preview, although it takes much longer to load here. And let's increase clarity. And bam, you can see the big difference that this makes. Let me go away from one-on-one detail to have a more broad view of the image. I think we went a little bit overboard there, so we're gonna lower that, but you can see this makes already a huge difference there. This is the before and the after. Now we have a more contrasty, colorful image. And I know I'm going a bit overboard, but I'm having fun, so I'm just going to apply that to the image. And there we go, we've applied Lighthouse. We have a super colorful, contrasty image from Siril. And now we can keep going and just place back the stars. So I'm going to save that. So it's going to be ACM2_LH for Lighthouse. Save it. Okay, so to place back the stars, we're going to go to image processing, star processing, star recomposition. Sure, let's select the file we just saved. Let's select the original star mask. There we go. And actually, I don't really like that the stars are this kind of weirdish, almost greenish color. So you know what? I'm going to kind of abandon that. So I'm going to open the star mask and maybe do some processing on the star mask itself. Like, yeah, you see it has this greenish color. So I'm just going to go and remove the green noise on the stars themselves. Immediately, that's much better. And I'm also going to decrease the saturation in general. So color saturation, and apply that. Then save that as another mask. I'm going to call it like star mask. Right, so it's one of the key points there. There's a lot of stuff that we can do. If we don't like something, we can just play with it And here I didn't like the stars, so I played with it. And so now we're going to go back to star processing, star recomposition, and again I'm going to select the starless image that we processed, the star full image that we processed, and that's much better in my opinion. And I can even limit the amount that the stars are distracting me by raising the black point. If I raise it too much, they're completely gone. You can see it's one of the techniques. It kind of makes the smaller stars kind of disappear. It's not scientifically accurate or anything like that, but you know, it helps have a decent image with fewer stars visible. And now I can do the usual stuff, which is save as a fit file, which is a requirement to do the star reduction later on. So I'm going to call that star recomposition.fit, save it. And now I can go to script, processing, and the star reduction script using the star method there. Because I know that I'll want to check the before and after, I'll actually run first the utility image window to keep a copy of this image. And now I can go back to the star reduction, apply it, and it's done. I'm going to close it, and we can look at the before and then after. And I like the after. We have still the stars that tell us, yes, this is in space, but the nebulosity, we're much less distracted from the nebulosity. And this can be our final image. And you can see we went really far. We went from a completely pink image to an image where we have the nice blue here and the red yellow at the edges. Really cool stuff, I think. I mean, personally. And yeah, this image was taken from Tokyo. So yeah, there you go. So now we can save the image like final.fit. That's my master image, save. And I can also save it again as a JPEG file to share, for instance. JPEG, there we go. And that is how we can process images, both LRGB from monochrome images, or one-shot color from a smart telescope broadband, or one-shot color from a smart telescope, or something else. That works as well with the light pollution filter, which is H-alpha oxygen 3. This flow should work fairly well. Now, this video doesn't cover the SHO kind of separate flow, or having two one-shot color images, one for H-alpha oxygen 3, the other for sulfur 2 oxygen 3. But if that's something that you want me to cover in here, let me know down in the comments and I'll do an additional video. While you're at it, you can like the video because it was a lot of work to make. I really appreciate you working through this video with me. Of course, the data is down in the description. And if you want to support me at no cost to you and you're planning on buying anything from Agena, High Point Scientific, Amazon, etc., if you do so after clicking one of the links that I have down in the description, it will help me out at no cost to you. So thank you so much for doing that. Otherwise, if you want to become a VIP member, make those really long to prepare and really long to make videos possible, you can join the channel as a member. It's the join button next to the subscribe button, or you can join my Patreon. The link is down in the description. Some of my Patreon ranks have access to my videos early and without ads. There's also a Buy Me a Coffee link down in the description. Much appreciated anytime you guys, you know it, you make all of this possible, and this amount I spent so much time on this video would not have been possible without your help. Thank you so much for your support. With that, otherwise, I hope this was useful. And yes, we used only free software this entire video. I did not use the RC Astro stuff. I did not use PixInsight, purely free stuff. And yeah, I hope this gave you an idea of what is possible with free stuff while you retain full control of what you want to be able to do. Let me know again what you thought of that in the comments. I hope it was useful. Thank you so much for watching. Don't forget, whenever you can, to look up at the stars, and I'll see you next time.